Welcome to lecture 3, which is on types of drone and their classification. In this lecture, you will learn what is drone, what are its utilities, and what are the various types of drones available and their classifications. So, a drone actually is also known as technically unmanned aerial vehicle, UAV. A drone is an unmanned aircraft. There is no pilot in it. It is guided remotely or autonomously from the ground. It's an aircraft which can fly without a pilot on board. So, that is the greatest advantage when we are using the drone. We are flying it safely because there is no pilot. The term drone and UAV, you will find in the literature, they mean the same thing, and these terms have been used interchangeably. So, it is one and the same thing if we call it unmanned aerial vehicle or drone. UAV or drones, they are low flying aircraft. So, they fly at a low altitude as compared to aerial survey that are used for collecting very high resolution images or laser point cloud data. So, we have varied kind of data from it. We can collect very high resolution images as well as we can collect point cloud data. Now, drones, they were initially used in the military and the army. So, they were used for a different purpose, they were invented for a different purpose, but later the technology was used for civilian applications because the data which we are getting from the drone system is also very useful for mapping the earth surface as well as applying these results for various developmental activities. Data from the drone which we are collecting is the excellent source of information for large scale mapping, because in many countries including India, the large scale maps are not available which are required for planning purposes, planning infrastructure. So, we can create these large scale maps with the help of the low flying drone systems, and also in addition we can create a very detailed digital elevation model, three-dimensional model of the terrain. So, we can view the terrain in third dimension on our computer without physically going to the site. Now, drone is a flying robot because it is flying with the help of a controlling device with the operator on the ground. So, it is remotely controlled, or second category is the flying autonomously through the software controlled flight plans. So, we have to have either the software based flight planning where it can fly autonomously, or we control with the help of the controller. It can work in conjunction with the several onboard cameras and sensors, means it houses many different types of cameras and sensors which you will learn in subsequent talk, including inertial measurement unit, IMU, very important unit which governs the movement of the drone in the 3 dimension, and global positioning system which gives us the coordinates of the ground points. Drone can also fly with remotely controlled by a human being or fly autonomously, as I told you, without any human intervention. So, we have two broad categories of these drones. There are several advantages. Some of the advantages we will discuss here. When we are doing land surveying and mapping using a drone, and we compare it with the traditional surveying method, ground based method, the use of drone is flexible. We can fly it anytime. It can operate day and night, that is the another biggest advantage, and even in cloudy condition it can take good images because it is flying at a low altitude. Drone can employ various sensors, so that is another big advantage, that we can have camera systems, we can have multispectral camera, we can have laser scanner, we have the other type of sensors like temperature sensors and so on. which offers us very economical approach to collect the huge data of the terrain. So when we are flying the drone to the area, large quantity of data from different sensors and scanners and camera systems can be collected about the terrain. The drone data collection is safe, as I told you, that it operates without a pilot in it, so it is controlled from the ground. So we can actually send the drone to the dangerous area, to those areas which are difficult to reach. And the data is very useful for creating 3D maps. So we can create digital surface model, we can create digital terrain model, digital elevation model, and we can do subsequently the modeling of the terrain. If we are having temporal drone data, we can actually find out what are the changes in the terrain surface, land surface over a period of time. So we can create change maps. The transportation cost of the drone system, because when we are moving in the field collecting the data, we have to see that the instrument which we are using or the system which we are using is portable, it is not very heavy. So its transportation is very easy and its mobilization time is also quite lower when we start preparation and start flying till collecting the data. So that saves a lot of time. So these are some of the advantages of using drone for land mapping. Now there are huge applications, very large number of applications of the drone, and only few are listed over here. As you can see that one of the biggest advantage could be in the field of surveying and mapping, which we will discuss in subsequent lectures. Then it is useful in aerospace, military, aerial surveying, law enforcement, search and rescue. The government, whenever there is a disaster activity taking place anywhere in the world, the drones are very useful in search and rescue activities. Then it is used in mining, conservation, pollution monitoring, oil, gas and mineral exploration, disaster relief, archaeology, agriculture. Agriculture, it is also playing very important role. We can monitor different types of crops and we can also find out the damage to the crops due to various disaster or flood. So in country like India, agriculture application is very, very useful. Now people have started realizing the use of this in construction activity. We can monitor the construction activity, we can monitor the movement of the material from one place to another with the help of the drone system. We can monitor the criminals and the terrorist activity. We can have motion picture filmmaking. It has been used a lot in the past also, and we are using in the hobbies and recreation and the light show activity, entertaining the people. So you can see from this small list that there are very, very large number of applications of the drone. Is not only for mapping purpose, not only for creating the 3D models, but for various applications which are useful to the human being. Now if we see the various maturity levels at which the drones are being used worldwide. So we have divided the maturity level into three categories. One is the low maturity level, second is the medium, and third is the high maturity level. Now if we look at the different applications, then the first one is the construction. So like in construction activity, it has been used at the high maturity level. Similarly, cinema, TV industry, energy sector, agriculture sector, infrastructure, real estate and entertainment. So you can see that these are those sectors which actually have reached the very high level of maturity, but there are sectors which need further attention. That means the drones are not being used to that extent as in the above area. If we talk about the insurance sector, if we talk about the safety and security, we are at the medium level here as far as the application is concerned. But there are certain area, research and science, logistic, humanitarian relief, where lot more has to be done to achieve to the highest accuracy. So these are the different level of maturity levels of drones applications. If we look at the classification of the drones, so there are actually literature is full of categorization based on several parameters. So there is no clear cut division of that. The classification has been done as per the payloads the drones carry, as per their weights, the size, the small or big, the function, the utility of that, the geographical range. So the range to which this can collect data, flight endurance, the time for which this collect the data, and the altitude, the height of the drone. So they are also classified further on the level of autonomy. That means being fully autonomous to the control by a remote pilot. They are also classified based on applications, whether we are using for civilian application or we are using for the military applications. In addition, you will find that a new classification is on the basis of the different energy sources, because the drones may be using the battery cells for energy, or solar cells, or traditional airplane fuels. So you will find that the classification has been done based on several parameters. So we have to understand these different classification and their utility. So if we talk about the types of drones, so broadly on the basis of the wings, if we want to classify them, broadly there are two kinds of drones. One is the multi-rotor drone, and in the first picture this multi-rotor drone is shown, where you have the four motors and the rotary. Then the second category is the fixed wing drone. So in the second picture here you can see a fixed wing drone. It looks like a small aeroplane. But there is a third category which is coming up, which is the hybrid system, and becoming quite popular because it is deriving the advantages of the multi-rotor and the fixed wing. So these are actually shown in the third picture here. So it has the rotors on the fixed wing. So multi-rotor drones out of the three are at present very common. But if we have to use a very large area mapping, then the drone with a fixed wing will be much faster to cover a large area in a shortest possible time. So depending upon the application, we will select whether we want multi-rotor drone or a fixed wing drone or a hybrid system. Now coming to the multi-rotor drone, the details of it, they are also called rotary drones or the rotorcraft or VTOL drones. Vertical takeoff and landing. They have rotors and propellers or the wings on the top, and these are available either with 1, 2, 3 or more propellers. We will discuss more later about this. But 4 double bladed, as you can see in this picture here, they are very common. So I think everybody is familiar with the 4 double bladed propellers. These blades, with the help of the motor, there is a motor below it, and generate lift to spin the propellers at a very high speed. So when they move at a high speed, it gives the lift to the entire drone system. Drone can fly upward, downward, backward, left and right, depending upon the movement of the propellers blades. They have very high advantages of hovering capability. If you have to hover, if you have to move over area, or high maneuverability, which are useful for many missions, especially in the civilian application. So it can actually stay at a point, it can move also. So if you want to continuously monitor one area, then these are very useful. They are typically more useful in situation where terrain is difficult or area is unreachable, because you can control it from the ground, send it to those areas and collect the images or data of the area. If you look at the classification of the rotary wing, I am showing you the popular one, the quadcopter. Quadcopter has actually, you can see the 4 rotors. Hexacopter, as the name suggesting, it has 6 copters, and octacopter has 8. So, each of this has their own merits and demerits. So, as the number of copters are increasing, the cost is increasing, but their weight lifting capacity or the speed is also increasing. So, depending upon the utility and depending upon the funds available, we will go for a particular kind of rotary wing drone. Coming to the second category, which is the fixed wing drone, looks like a small aircraft. It actually requires a runway to take off and landing. So, it will fly horizontally first and then it will take off, and then similarly for the landing also it requires a runway. Whereas, in case of the rotary wing, it actually goes vertically up. So, you can fly that from the top of the building, from a small playground, something like that. So, fixed wing drones have generally long endurance and can fly at high cruising speeds. The speed is much higher and they have the high or long endurance time. They push the wings through the air to generate the lift and move the drone in a forward direction. So, due to that lift which is generated by these wings, okay, the drone is moving in the forward direction, and that is why the speed is much higher than the previous one. Now, if we compare the two together, the fixed wing and the rotary wing together with the 3 parameters. First is the mechanism, the second is the advantage, and the third is limitations, because every system has its own limitation. So, in the mechanism, the fixed wing drone lift is generated using wings with the forward air speed. In the rotary wing, the lift is generated using those blades which are revolving around a rotor shaft. Advantages of fixed wing is the simple structure, usually higher payload they can carry, and there is a speed, higher speed also. They can hover, rotary wing can hover actually in any direction, left, right, forward, backward, as I told you, and it is a VTOL, vertical takeoff and landing. Now, coming to the limitation, the fixed wing drone need to maintain forward motion, need a runway for takeoff and landing, and sometimes this could be a limitation to use a fixed wing drone. Rotary wing usually lower payload, you cannot carry very high large amount of sensors which have the weights, lower speed, and they have the shorter range to cover. So, these are the merits and the demerits of both types of thing. If we look at now the several parameters, fixed wing versus the rotary wing, so it shows that where the fixed wing is qualifying and where the rotary wing is qualifying. For example, if we are talking of the suitability of the drone, then fixed wing is much more suitable because of the higher range and high carrying capacity of the payload. So, efficiency for area mapping would be much more in case of the rotary wing type of a drones. So, these are some of the advantages and disadvantages. Now, there are various commercial drones available worldwide in the market and their salient features. So, one has to see first of all what is the application in hand, for what purpose the drone is being used, and then looking at those specification and the characteristics of those drones, we must actually decide which one is better for us. But one thing is common here, when you look at the flight time and the payload, these have 15 minutes to 30 minutes sort of the flying time, which basically can be used to collect the data optimally, because this time 15 minutes or 30 minutes time sometimes may not be sufficient. So, you need extra pair of batteries, or you need to charge the battery and fly it again if your planning is not perfect. So, here planning to collect the data is very important, and what we call as the flight planning, which also you will learn little later. Now, the second category of classification is based on the operation of the drone. So, there are 5 different types of drones One is the remote human pilot. So, it is a real time control by a remote pilot. The second category is the remote human operator. So, human operator provides the flight parameters to invoke the built-in functions for controlling the vehicle. That is called the remote human operator. The third category is the semi-autonomous category, where human controlled initiation and termination is required. Autonomous mission execution is also there. So, that is why this is semi-autonomous in nature. The fourth category is autonomous. It is the automated operation after the human initiation. So, little human initiation is required here also. The last category is the swarm control, where you have a group of UAVs which are flying together, and cooperative mission accomplishment via control among the vehicle is done in that class. The other drones which are based on their operation are classified like a toy drones. So, these are small, mini and nano category of the drone. They are like a quadcopter. They are inexpensive, they are not very costly, and they are good device to start for the beginners. So, those who are beginner, they can learn with this. Then the second category comes the hobby drones. They are mid-sized drone. They are used by the novice flyers with some experience. They have the prior experience, and many have cameras and other sensors attached to the hobby drones. Then third category is the professional drones. They are, as the name suggests, they are very high-end copters with 4 or more propellers. They have high definition cameras and other sensors for collecting aerial photography and associated data. They have more features along with the longest flying time. Then the next category is the selfie drone. So, there are small flying cameras. They are very compact, they are easy to carry from one place to another, and they enable capturing the selfie shots. From a unique perspective position, you can collect the selfie and you can share it on a social media sites and so on. So, these are also different types of drone based on their operations. Under this category, the next one is the racing drone. They are quite small. They move very fast because they are used for racing purpose. They are agile quadcopters with an onboard camera that will transmit the real time video back to the pilot on the ground. Then the further innovation brings the foldable drones. As the name itself is suggesting, there are with the motor arms that can be folded and unfold. Because of the folded arms, they reduce the risk of impact, and they are easy to transport. They are very compact, can be stored inside a travel case or on the backpack. And then the last category under the operation is the inflatable drones. The inflatable drones are easier to transport because they can be inflated at the site. Whenever we are using, they can be inflated very fast, even with the small air pump. They are waterproof and can fly safely on land, on water, and even fly in the rains. So, these are the other categories of the drone based on the operation. Now, if we look at that size, if we classify the drone on the basis of their size, typical classification is the micro and the mini drones, which has the micro means weighing less than 2 kilogram, and mini drones will be less than 20 kilogram, between 2 to 20 kilogram. Both mini and micro type of drones have their limitations, with most computer embedded system due to the limited space in that. They have limited power resource, can fly for a short time, increasing computation requirement, complexity of the application and time to survey requirements, etc. There are two major type of small drones when we are talking. The first one will use the flapping wings to fly like an insect or the bird, and the other one will use more or less the conventional type of configuration. Usually it is rotary wing for the micro size range. Now, very small drones which are ranging from micro sized and they are about the size of a large insect with dimension of the order of 30 to 50 centimeter. So, very small size. Then we have the category heavier drones also. So, under very small drones, if you see several classes are there, mosquito, which is about 35 centimeter, 14.8 inches long and 35 centimeter total span. So, these are very small drones. Then second category is the skate fuselage wing, which has a wing span of about 60 centimeter, 24-inch and length 33. It folds in half so that it is easy to carry also, to transport and for storage purpose. The third category is the cyber quad mini, which has a 4 ducted fans and the total outside dimension including the fan shroud is about 42 by 42 centimeter. And this drone resembles like a flying toy called the parrot AR drone. So, you will find that they are very small drones as far as the size is concerned. So, these are the pictorial representation of the drone. So, this is the first one is for the mosquito drone, the second picture is for the skate drone, it looks like the skating platform, and the third one is the quad mini drone. So, you have the 4 rotary wheels in it, wings. Then further classification on the based of the size. The other type of drones are the group of lightweight aerial systems which are called blimps. Now, such as we have seen the balloon, they look like a balloon, or the airships which are lighter than the air and they can go up and have a long flight endurance. They fly at a low speed and generally are very large size. So, you can see here the blimps in the form of the airship and in the form of the balloon. So, they can stay in the air for a longer time and can collect the data for the area. Classification based on the size. So, in addition there are flapping wing drones which have small wings similar to birds and flying insects. So, these kind of drones which have the flapping wing has the advantage because when they are flying they look like a bird or insect and they are able to fly over the area and collect the data because there is always a confusion, looks like a bird. So, we can actually collect the data from this without realizing that it is not a bird and it is actually a sensor platform. But for the flapping wings drones, there are issues which are related to the aerodynamics. Now, classification based on the size, in general, if you look at the different size drones, the large drone will carry more payloads, it is obvious. They will fly at a higher altitude, move a longer distance, and hence they have better flight endurance and capability than the small drones. So, this is the table here which indicates the category according to their size, and here we have the micro, mini, small, tactical, mail, hail and strike combat type. So, in this particular table the comparison is given as far as the weights is concerned, operating altitude, radius of mission, endurance, what is the altitude they can achieve and what is the typical yield. So, depending upon the application we will go for the size of the drone. Now, classification based on the altitude. So, we have low altitude and we have the high altitude platform. So, in one is called lap and the second category is called HAP. So, under HAP they have the long endurance, they have wide coverage, they are quasi stationary and their altitude is quite high to 17 kilometer. But the low altitude platform, they are fast and flexible deployment, they have quick mobility, cost effective and fly up to several hours. So, again depending upon the altitude, at what altitude we have to collect the data, we will go for lap and HAP. Classification based on this altitude, as I already explained you, that the lab, they can go tens of meters to few kilometer, but less than 10 kilometer they can fly. But if we want to fly above 10 kilometer or more, then we have to go for HAP type of drones, and they can go into the upper layer of the stratosphere and collect the data. Now, classification based on the sensor system, the sensor which they employ. So, broadly, there are two popular sensors which are employed. One is the photogrammetry based and another is the LiDAR based sensor. So, sometimes the drone can carry both the sensors. Photogrammetric drones and the LiDAR drones are actually quite different from each other, because the nature of data which is collected is different. Even if we get the same output at the end, three-dimensional model, but the three-dimensional model may look similar, but the nature of data which has been collected by both the sensors, there is different. So, we have to make a choice sometimes between the photogrammetric drone and the LiDAR drone, and it depends upon our application whether we want the photographic data or we want the point cloud data at the end. Classification based on application part. Earlier drones were most often associated with the military application, as they were devised for military application, where they were used initially for anti-aircraft target practice, intelligence gathering and as the weapon platforms. But nowadays the drones are used for a very large number of civilian application, for recreational purpose and for commercial applications. So, depending upon the applications, they have been further categorized. So, you can see in this particular table, the first column shows what are the different military uses. Reconnaissance could be target acquisition, battlefield damage assessment, landmine detection, combat role. So, there are many applications for the military use. And when we come to the civilian use, it could be taking the aerial photograph of the area, applying in the agriculture and forestry sector, to the smart city applications, to fire service and the forestry, to gas and oil supply company for meteorological services. So, large number of applications are there today when we are using it for civilian purpose. Some commercial drone manufacturer. Now, looking at the application part, there are lot of applications of the drone. So, the commercial manufacturer came forward in the market internationally and they started manufacturing different type of drones. So, this is just exemplary list. There could be many more commercial drone manufacturers all around the globe. Now, if we look at the future in land mapping, as far as the drone survey is concerned, civil engineers, real estate manager, construction companies, mining companies and government agencies, they are now using the drone to collect the data and to do the planning and developmental activities from that latest data, high resolution data which is being collected from the drones. Now, we can actually merge this drone technology with the other technology around us which is available, Internet of Things, artificial intelligence, augmented reality, virtual reality. So, there are several emerging technologies where this data can play very important role, and that is why it has opened the new avenues and very innovative application of the drones. These are some of the suggested readings further. Thank you very much.